Hello and welcome to another video. In this video we're going to be working on range sum of assorted subarray sums. And in this one you're given an array nums consisting of n positive integers, and you computed the sum of all empty non-contiguous subarrays from the array and sorted them in non-decreasing order, creating an array of this many numbers. Return the sum of the numbers from left to right and their one index inclusive, since it can be big modded by this. So basically you can get all possible sums, and I'll kind of show you how to do that. And then you get these, and then you sort it, and then you just return the ones that you want. So for example, in this, they want 1 through 5, so this is 1, 2, 3, 4, 5, because it's one indexed. So that's 13. In the second example, same kind of thing, you get all the sums, and then you want 3 and 4, so these two. And then in the next example, you want 1 through 10, so let's just walk through this like step by step. So let's say we have an array of 1, 2, 3, 4. How do we get all the sums? So the easiest way to do that, and basically to get all the sums, there's roughly n squared of them. The easiest way to do that is you start at the first number, and then you say like, okay, my first sum is the first number, then I'll add this number, then I'll add this number, then I'll add this number. So let's kind of do that. So our first sum is a 1, then we can add this number, so then we have 3, then 6, then 10. And that's if you start at the first number. So that's the subarray's equivalent of like this, 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 and this. Then if you go to the next number, the sums are 2, and then you add 2 plus 3, so 5, and then add the 4, so 9. So that's how you get all those, right? So you basically think about like, what are all the possible subarrays? So every subarray that starts with 1 is like 1, 1, 2, 1, 2, 3, 1, 2, 3, 4. Every subarray that starts with 2 is 2, 2, 3, 2, 3, 4. Then with 3, same kind of thing. So 3 and then 7. And then with 4, there's only 4. So these are all of our sums. And when you sort them, they give you this 1, 2, 3, 3, 4, 5, 6, 7, 9, 10. So you can basically do this in n squared time, where you start with one number and then you get the sum of that number plus the one after, plus the one after, plus the one after, plus the one after, and every time you get a new sum, you just record. Then once we get all those sums, we can just sort our array. So that's what they did here. Once you get all the sums, you can sort your array. And then all we have to do is just loop through the indices and add those together. And so I wanted to briefly mention there is another solution that doesn't actually get these sums. It's like a binary search sliding window one. And that solution is like a LeetCode contest level problem, I'd say. So I'm not going to be showing that one for like a medium. If it was like a hard or very hard or something, I'd be doing that one. But that one you need to know a lot. It's very confusing in my opinion. So I think this is the one that like is expected for this level of a problem. So this is the one that we're going to be doing. So essentially that's what we're going to do. We're going to get the sums in n squared time. And that's the other thing is you should know that this is like kind of good to know. So if our array is length 10, the number of total sums is this. So this is also good to know, because if we start at the first element, let's actually use a thing here. So if our array is length 10, that means for the first number, we're going to have 10 sums. Then we'll have 9, then 8, then 7, then 6, and so on. So it'll basically be the sum of 1 through 10 added together, which is this guy right here. That's just an arithmetic sum. So good to know that this is roughly how many you have. Okay, and so we can code this guy now. So basically what we're going to do is we're going to first create a sums array, and that yeah, so it's going to be an int array, and its length will be n times n plus 1 over 2. Okay, and we'll just create an index where we're going to be writing into, so we'll say it's 0 at first. Okay, so now we just need a nested for loop here. And another one. We'll start at I. And we're gonna keep track of our total sum because we're adding a new number every time. So we'll just say in sum for it's gonna be this. And then we will add this, and every time we have a new sum, we will record it into sums. So sums s will have that. Then we need to sort. So then we need to have a result, and we need a mod variable to keep it small enough. So we'll make this 10 to the 9 plus 7. So let's write it like this. Okay, and then yeah, and then we just loop again. So, and we're gonna loop from left to right, and this is left ind. So this is one index. So left 1 means actually I needs to be here, and I is less than right. Then we just do result equals result plus that sum. So sums I, and then we can just mod it by mod and return. Okay. And yeah, so that's like the medium solution to this, and it's okay. Yeah, the other one is n log n, but like I said, that one wouldn't be an interview question. Then that's like a significantly harder problem. So this one is n squared, and then you're also sorting an array of length squared, so that's log n squared. And space. So we actually created our results, so that's n squared. And yeah, it's gonna be all for this one. Hopefully you liked it. If you did, please like the video and subscribe to the channel, and I'll see you in the next one. Thanks for watching.